Here's the code that we'll be running today. This is modeled after some code that I was working on with a customer. Their challenge was that it would take 45 seconds for the wind tunnel to recharge before they could do the second run of it, and they would be doing run after run all day. So they had to do all of their calculations and be ready for the next run before that 45 seconds was up. So to them, seconds were precious. Let's see how we took their code and modified it using the profiler to make it run faster. I'm going to move my screen capture up here so we can see that I'm going to go to the Tools and Profiler. Here the profiler is open, and we know that we were editing main, so MATLAB brings that up as the code to run, and we're just going to hit Start Profiling. In a few seconds the code will be run, and what's going on is MATLAB is taking diagnostics of the code to find out where the most time is spent. If we look at this report, we can see that there was the function main, which we ran, and a sub-function called doChannel that was also run. Due to the screen resolution, I'm going to have to scroll over to see the rest of this chart. Alright, so what we see here is that main took 18.275 seconds. However, most of that time was not spent in main itself, but in the sub-function called doChannel. So that's really where all of our bottleneck must be. I'm going to scroll back here, and let's look at doChannel. Okay, when we look at this, it's going to be difficult at this screen resolution, but we can see that there is a bunch of lines where the most time was spent, and if we scroll over to the right, we can see the time plot. Clearly, line 20, the top line here, is where most of the problem was. 78.7% of the time was spent there. Let's go look at that line of code and see what was going on. It's colorized based on time, and we can see that line 20 is bright red because the most time was spent on there, 14.1 seconds. If we scroll down a little bit, we can see that 2.4 seconds barely shows up as pink because so much time was spent on line 20. So clearly that's where we need to spend our time optimizing. Now if you read this, you can see that these two lines here are actually an alternative version of these three lines. They do the same thing, it's just that one of them goes faster than the other. So the profiler makes that very clear, and so I know that I need to get rid of line 20. It is not as good as lines 25 and 26. So that's how I can make those decisions. And it shows me where I need to spend my time updating my code. Okay, I hope this was helpful to you. There's a lot of other tools in the profiler that you would want to use, like mlint and so on, but I just wanted to give you a quick idea of how you can use the profiler to improve upon your code.